In this video, we are looking at negative angles and angles larger than 360 degrees. Well, let's start and look at angles larger than 360 degrees on a graph. Here we have the graph of y equals cos theta. This is the cos graph that you did in grade 10. Okay, so if we look at the specific point there, let's take point A where x is 60 degrees and y is 0,5. If you carry along on the cos graph, after 360 degrees, you will once again get the same value 0.5 on the y-axis when x is 420 degrees. If you carry on for another 360 degrees, you'll come to point C, where the function value is once again 0.5 on the y-axis, but the x has now changed to 780. Okay, so every 360 degrees we get the same value because this graph is periodic. Okay, so just remember this when we're working with angles. So if you have to find the ratio of cos 780, you might as well take this ratio of cos 60. Why? Because they're exactly the same if you look at the graph. So if you get a large angle from now on, a large angle that's larger than 360 degrees, greater than 360 degrees, you can just subtract multiples of 360. By the way, that is how we write multiples of 360. We say 360 degrees times k, where k is an integer. So that's 360 times 0, 360 times 1, times 2, times 3. So k can be any number from 1 to infinity. Then we get all the multiples of 360. Larger angles. Let's look at larger angles on the Cartesian plane. If we have a cos 60 on the Cartesian plane, it's in quadrant 1. Now add 360 to 60 degrees. We get 420. That means we're going 60 plus another 60 degrees. Then we're still in the first quadrant. We still have the same value, and that is a half. Let's go for 60 and then another 360, another 360, two 360s. And we will still have exactly the same triangle that we originally had. So instead of working with a 780, we are going to subtract as many as possible 360 multiples until we end with an angle in the first quadrant or any well-known quadrant, which is 1 to 4. Okay. So that is how we handle an angle larger than 360. Let's see how we handle a negative angle. Okay, so negative angles are measured clockwise from the positive x-axis. If theta is that angle, anti-clockwise in the first quadrant, then negative theta is an angle in the fourth quadrant. So what is sine in the fourth quadrant? Well, it's negative y over r, which gives you negative sine theta. What is cos in the fourth quadrant? Well, cos is x, which stays positive, over r. So cos of a negative angle is equal to cos of the same angle without the negative. Tan of a negative angle, tan in the fourth quadrant is negative. So remember, sine of a negative angle, then the sine goes to the front. Cos of a negative angle is the same as cos of the positive angle, and tan of a negative angle is negative tan of that angle. Wow, 3 new things to learn. Move on and we say, how do we change angles, negative angles to positive angles? Well, here are our formulas. You can learn them by heart, or you can figure it out by just thinking of an angle in the fourth quadrant. So if you have a little sum like this one, sine minus 30, you just say, where is minus 30? It's fourth quadrant. What is sine there? Negative, and the answer is negative sin 30. If you have cos negative 150, you just do the same principle. You use this formula. The minus just falls away because that is not fourth quadrant anymore, but the principle stays the same. The cos of a negative angle is equal to cos of the positive angle. There we go. Now 150 is second quadrant, there we go, and we get negative cos 30. If we have something funny like this, which is an unknown angle, nobody has seen that reduction formula yet, we recognize that we can take out a minus. and then we get 180 plus theta, which is third quadrant, tan in, okay, but now it's first tan of a negative angle. What is tan of a negative angle? Well, it's negative tan of that angle. And tan in the third quadrant is once again positive, so it stays negative tan theta after you've thrown away the reduction formula. Okay, so some of these sums we've done, the last one we did, had a funny kind of reduction formula. It's something we haven't seen. Okay, so now I'm going to show you an alternative method that you work with sketches and not necessarily with reduction formula. So let's look at these four sums and let's do them and see what we get. Okay, so we're going for the first one. You draw a sketch to get the quadrant. Okay, it is negative 270 minus theta. Okay, where would negative 270 sit? That would mean you have to go 270 degrees, 90, 180, 270 is exactly there. That is negative 270 degrees. Now we need to go negative theta. That's clockwise. Theta is always a acute angle. So there's negative theta. Where did we end up? In quadrant 1. What is sine in quadrant 1? It's positive. So the sign will be positive, but because of the 270 is treated the same as 90 as co-functions, the sign must become a cos. Tough, eh? The next example also has a funny angle that we don't recognize. Okay, let's go minus 180. That's negative 180. Find another negative theta. Theta is an acute angle, so it's only in between 0 and 90 degrees, and we are now in quadrant 2. What is tan in quadrant 2? It's negative, and we've done that one. Okay, let's look at this one. Where is theta? Well, theta is a positive angle that you draw going anti-clockwise. Now we're going to go negative 360. That means clockwise 360. That is 180. 360 would be right there. And I'm still in quadrant 1 where cos is positive. This last one, 810 plus x. 810 is too large. It's larger than 360, so we can at least subtract 2 multiples of 360. So what is 810 minus 720? Gives you 90. I recognize this as a co-function sum because of the 90. Sine in the second quadrant is positive, so the sign is going to be positive, and 90 says that the sin must go to cos, so it becomes positive cos x. Okay, that was quite a lesson. Please go through it slowly because this stuff is quite difficult. Goodbye.